In this video, I'm going to go through my Max project, how I created each sound, as well as the way my sap patches are being laid. To start with, a universal metro object sends bang every 20 milliseconds. That sets a counter object to count up and create a sequence of 6 different images that roll through every static bang. These images are stored in this sap patch right here, and in turn they are being displayed through an FPIC object at the bottom of the screen. With regards to the sounds, 6 sap patches were created in order to match the visual context of each image. For the first patch, which is right here, 2 main sources of sound were used. 2 phaser objects go through an SAH tilde object that captures one signal while it outputs a value whenever it rises above a specific threshold value. This in turn drives a cycle oscillator. The second sound is a frequency swap that is being equalized through a notch filter and then sent to multiple delay lines to achieve a ping-pong delay effect. My second sap patch is composed by 3 sound sources. The first one simulates the sound of a wind turbine by using a noise and pulse generator, while there are certain frequencies being subtracted by a low-pass filter. I'm talking about the chain right here. The second one is just a ramp-up of frequencies that are driven by a cycle oscillator to create a subsonic vibe for this patch. Last but not least, a simple additive synthesizer emits a swipe of frequencies at a predetermined ratio of 1000 milliseconds. Following on to the third sap patch, which simulates the ambience of a dockyard environment by using a sample of seagulls played back by this playlist object tilde with a drilling noise. The drilling noise right here. This sound is made similarly to my first sap patch by adding 2 sinusoidal frequencies in order to drive a saw oscillator that is filtered through a loris tilde object. The fourth sap patch in a row is an interesting result of a sonic interference. A looped sampled is being played back while it's been modulated by a pink generator sap patch, which is this one. Here the noise is sent, let's see that again. Here the noise is sent through a low-pass filter where its cutoff frequency is being randomly tweaked over time with the use of a drunk object. Delay has been added and finally scaled to output the final result. Let's move on to the fifth one. This was the least inspiring one, just because I'm not aware of how a coal mine environment would sound like. Again, a ramp-up of various frequencies interfere to create the sound of multiple pitched sirens. You can see the 3 different layers multiplied up by a value of 0.3 to reduce the amplitude in order to output them. For the last one, a triangle waveform that its temporal characteristics have been changed is multiplied with the outcome of a frequency sweep emitted by 2 other signals. Finishing up, pink noise is layered up with the use of a sinusoidal and a triangle waveform. These again are filtered and delayed in order to be scaled to reach its output destination right at the bottom of the chain. I hope you enjoyed. Thanks for watching.